The colligative property problems that we're going to do are boiling point elevation and freezing point depression. So boiling point elevation means that you're going to take your original boiling point and you're going to increase it, elevate it, or you're going to take your original freezing point and you're going to depress it, or you're going to make it go down, decrease. So looking at your problems, you're going to need to first know your formula that you need to do the problem. The formula is delta T. The triangle is a delta. This triangle means change in temperature. So what is the difference between the original freezing point or boiling point and the new freezing point or boiling point? T's temperature is equal to your K value times little m. Little m is molality. So your delta T, that's going to be degrees Celsius. Your K value is a constant. It's going to be given to you in the question. So it'll say like your K value here or your K value here. You'll see a B for boiling and F for freezing. That's all that means. And then your little m, this is moles of solute over kilograms of solvent. So you'll have to solve for that first probably and then plug it into the equation. So when we look at our problems, like number 1, this one says, what is the boiling point elevation when 11.4 grams of ammonia, which ammonia is NH3, is dissolved into 200 grams of water? The K value is 0.52. What is the new boiling point? So they're actually asking 2 questions there. In the first question, it's asking us to figure out what is the boiling point elevation. So what is our delta T, our change in temperature? Our delta T is equal to your K value, 0.52, times your little m. We need to solve for little m first. It says that we have 11.4 grams of ammonia dissolved into 200 grams of water. That means that this, your ammonia, is your solute. Your 200 grams of water is your solvent. So we're going to take our 11.4 grams of NH3. We need to convert that out to moles. So 17.04 grams is the molar mass. That's equal to 1 mole. So 11.4 divided by 17.04, 0.669 moles. For my kilograms, I just moved my decimal place 1, 2, 3 times. That had 3 sig figs. I need 3 sig figs after. So we have 0.669, 0.200. When I divide that out, that's going to give me my little m value. So 0.669 divided by 0.2. That gives me 3.35 for my little m. For my concentration. So this, I'm going to plug in over here now into my formula, 3.35. So now I multiply those two together, 0.52 times 3.35, you get 1.74 degrees Celsius. So that's my boiling point elevation. With my boiling point elevation, the second question then says, what is the new boiling point? So when the question says, what is the new boiling point, you're going to take your original boiling point, which is water, and you're going to add, because boiling point adds, freezing point subtracts, you're going to add your change in temperature. Now, if you aren't sure of the boiling point or the freezing point of water, I put it on the front of your lab right here, or front of your homework packet right here. So it says the boiling point of water used to be 100 degrees Celsius. So you have 100 originally. The change is 1.74. We're going to add those two together, so you get 101.74 degrees Celsius. So that's the new boiling point when you add your ammonia to water. Freezing point depression problems are exactly the same thing. It's the exact same equation. You're going to have a K, you're going to have a little m. The only difference there, actually it isn't even a difference, it's just some of the problems are going to give you the change in temperature like this one does, and it wants to know how many grams of silver need to be dissolved into 1,120 grams of ethanol. So this problem we're going to work backwards. I'm going to write the equation back over here. K times your little m. We are given our change in temperature, the 0.25. We're given our K value, 1.99. I don't know my molality. So I have moles on top because it says silver is dissolved into ethanol. So you have 1.12 grams, which will go to these grams will go to kilograms, so 1.12 kilograms. I need to get my moles all by itself. So when I get the moles all by itself, I first need to divide both sides by 1.99 to get that to go away. 0.25 divided by 1.99. 2 sig figs, 3 sig figs. So this is going to have 2 sig figs. So 0.13 is equal to my moles over 1.12. Now I need to get my moles all by itself. When I get the moles all by itself, I'm going to multiply both sides by 1.12. So 1.12 times 0.13. 3 sig figs, 2. So that means that I need 2 in my answer. So you have 0.15 moles. Well, actually I'm not done. Sorry, I just boxed that in. But it says how many grams of silver. So because the question says how many grams of silver, I'm going to jump over here to my piece of paper. I need to take my moles and convert it to grams. How I do that is I'm going to use my molar mass. 1 mole of silver, when you look it up on the periodic table, 107.87 is the mass. Oops, 107.87 grams. Moles cancels, so we take 0.15 times 107.87. With 2 sig figs, we should get 16 grams. So we'll check the answer in the back. Page 13. And you should get 16 grams. So both of the problems are identical. It's delta T, either F or B, depending on which one you're doing, is equal to your K value, F or B, depending on which one you're doing, times your little m. We just need to remember that little m is your moles of solute divided by kilograms of solvent. It's molality.